Mrs. Foster here. Today we're going to do just a really quick video talking about the important information that we can tell from each equation. So far we've talked about three different types of equations that we can write to represent a line. We have standard form, slope-intercept form, and point-slope form. So what I'm going to recommend that you do for this lesson and for this video is in your notebook, go ahead and make a table that looks something like this. You can write linear equations, take a whole page for it. What does it look like? What can we find? When should we use this form to write the equation? And then take the time to actually draw out a nice coordinate plane at the bottom so you have an example of each. So right now, go ahead and pause the video and go ahead and make your own table like this so that while we go through the rest of the notes, you have a nice organized place that you can look back at when you're working with linear equations moving forward. Okay, now that you have copied down your table, let's go ahead and start with standard form. We've talked about standard form before, so we should know what it looks like. This is ax plus by equals c. And when we use standard form, we were talking about x and y intercepts. So that's what we can find. What does it look like? Here's our form. What can we find? X and y intercepts. So when should you use standard form? Most of the time, standard form is not that helpful, not when it comes to graphing or looking for information. So moving forward, we won't be using standard form that much. A lot of times you're converting from standard form. But if you're ever given your x and y intercepts, then go ahead and use your standard form. That's fine. It might be easier to use slope-intercept form or point-slope form, but it is still very important that you know what standard form is and how we can use it if it's given to us. Now for the example here, if you're going to use standard form to graph, then like we've done before, you're going to figure out what's your x-intercept, what's your y-intercept, and then use those 2 points to graph. Looking here, my x-intercept, let's see, I'm going to scroll down here so I can actually write on my graph here. My x-intercept is if we were going to cover up our 3y because we're putting a 0 in for y. So my x-intercept would be 5x equals negative 30. So x equals negative 6. So this point right here would be my x-intercept on the graph. The y-intercept is going to be if I put a 0 in for x, so negative 3y equals negative 30. Well, negative 3y equals negative 30 when y equals a positive 10. So now to graph this, I'm just going to draw a line that goes through those 2 points. Just, oops, like this. There you go. And I graphed the equation 5x minus 3y equals negative 30 when it's given to me in standard form. All right, next slide. Slope-intercept form. So going back to the table that you have there, our first column, what does it look like? Well, slope-intercept form, we talked about that on day 1. That is y equals mx plus b, where m represents our slope and b represents our y-intercept. What can we find when something's written in slope-intercept form? This one's named really well because if something's written in slope-intercept form, we can identify both the slope, our m, and our y-intercept, our b. So when do you think you should be using this form? I like to use this form whenever I'm given my y-intercept and slope. The other thing is, if I'm ever given 2 points, then I can also write it in slope-intercept form, especially if one of those points given is the y-intercept. If I'm given 2 points, I can use those 2 points in my slope formula to identify my slope. All right, scrolling down. If you need to, please pause the video so you can actually finish filling out your table here. Moving down here. So in this example, they gave me y equals 3/4 x minus 5. Well, I know my slope is 3/4. My y-intercept is negative 5. So similar to how we did it with standard form, I'm going to start by graphing my intercept at this point, negative 5. And then because my slope is 3/4, 3 over 4, remember we go rise over run. So I'm going to go up 3, 1, 2, 3. I'm going to go over 4, 1, 2, 3, 4. So those are the 2 points that I should be going through on the end there. Let me mark those in red so you can see them. This point And this point, if you wanted to, you could do that again, count up another 3 and to the right 4. When I graph this line, I should be able to see, I'll move this so it's a little bit more accurate and actually goes through those 2 dots. The graph should go through those 2 lines, but because my slope was a positive 3/4, my graph should have a positive line, and it does here. There we go. So I've got 3/4. That's what the graph should look like for that one. Last form. We've talked about standard, slope, intercept, and also we have point slope form. So day 2, we talked about point slope form, and in point slope form, we have y minus y1 equals m times x minus x1, where m is our slope, x1, y1 represents one given point. Like slope intercept, point slope form is named very well because what can we find when something's written in point slope form? You guessed it, we can find our slope and 1 point. So when should we use this form? It says from, it should stay form. That's going to bug me if I don't change it. There you go. When should we use this form? It's possible it was like that on every page and I just now noticed it. When you have slope and 1 point, or if they ever give you just 2 points, to any 2 points, it could be your y-intercept, but it doesn't have to be your y-intercept. But if that's the case, then you can quickly and easily write something in point slope form, substituting your slope in for m, substituting your point in for x1, y1, and just making sure that you're paying attention to those negative signs. All right. Last example here for graphing. Y minus 6 equals 4 times x plus 7. My slope is 4. My point, my x value, you'll see over here by x, is a positive 7. So it's plus 7. But remember, with the point that they gave us in the form, it should be x minus x1. So if it's positive 7, that means my x value must have been a negative 7. Y minus 6, so it's going to be a positive 6. So I'll start by graphing that point, plotting that point on my graph of negative 7, 6. And I'll use my slope again, going up 4 over 1, rise over 1. Remember, slope of 4 can also be written as 4 over 1. So if I go up 4, 1, 2, 3, 4 over 1. If you wanted to, you could do the same thing, going 1, 2, 3, 4 to the left one. And then I'm going to connect a line that goes through both of those. Did I count right? 1, 2, 3, 4. Yep, just wanted to double check. All right, we'll go through this point to this point, extend that line a little bit, and there we go. All right, when you're done filling out your table, it should look just like this. So we've got all 3 forms, standard form, slope, intercept, and point slope form. What we can find or what it tells us, when we should use this form, and an example of what a graph looks like when we're given standard, slope, intercept, and point slope. Hopefully this helps you out getting started looking at both in all 3 types of forms of linear equations. We're going to continue using all 3 of these in intermediate algebra, but you'll also see these again in geometry, and then one more time in advanced algebra, and then after that, depending on what math class you go into. But these are 3 forms that you should know. You should memorize this information at some point, but in the meantime, now you have this handy dandy chart that you can go back and reference. If you have any questions, make sure that you're reaching out to your intermediate algebra teacher. Have a great day, guys.